In our previous lesson, we saw how we can implement a stack. We saw two popular implementations of stack, one using arrays and another using linked list. A warrior should not just possess a weapon, he must also know when and how to use it. As programmers, we must know in what all scenarios we can use a particular data structure. In this lesson, I'm going to talk about one simple use case of stack. A stack can be used to reverse a list or collection, or simply to traverse a list or collection in reverse order. I'm going to talk about two problems: reversal of string and reversal of linked list. And I'm going to solve both these problems using stack. Let's first discuss reversal of string. I have a string in the form of a character array here. I have this string hello. A string is a sequence of characters. This is a C style string. In C, a string must be terminated with a null character, so this last character is a null character. Reversal means characters in the array should be rearranged like what I'm showing here in the right. Null character is used only to mark the end of string. It is not part of string. Okay, there are a couple of efficient ways in which we can reverse a string. Let's first discuss how we can solve this problem using a stack, and then we will see how efficient it is. What we can do is we can create a stack of characters. I'm showing logical representation of a stack here. This is a stack of characters and right now it's empty. And now what we can do is we can traverse the characters in the string from left to right and start pushing them onto the stack. So first H goes into the stack, then the next character is E, then L, then we have another L, and then the last character is O. Once all the characters in the string have gone into the stack, we can once again start at the 0th index. Now we need to write the topmost character in the stack at this index. We can get the topmost character by calling top operation, and now we can perform a pop, and now we can go to the next index, fill in whatever is at top of stack, and perform a pop again. We can go on doing this until stack is not empty, so all the positions in the character array will be overwritten. So finally we have reversed our string here. In a stack, whatever goes in last comes out first. So if we will push a bunch of items onto a stack, and once all items are pushed, if we will start popping, we will get the items in reverse order. First item pushed onto the stack will come out last. Let's quickly write code for this logic. I'm going to write C++ here. Things will be pretty similar in other languages, so it doesn't really matter. What I'm going to do in my code is I'm going to create a character array to store a string, and then I will ask user to input a string. Once I input the string, I will make a call to a function named reverse, passing it the array and length of string that I will get by making a call to string length function. And finally I'm printing the reversed string. Now I need to write the reverse function. In reverse function, I want to use a stack of characters. We have already seen how we can implement stack. In C++, we can create a class named stack that would have an array of characters and an integer variable named top to mark the top of stack in array, and these variables can be private, and we can work upon the stack using these public functions. In reverse function, we can simply create an object of stack and use it. This class can be an array-based implementation of stack or a linked list-based implementation of stack. It doesn't really matter. In C++ and many other languages, language libraries also give us implementation of stack. In this program, I'm not going to write my own stack. I'm going to use stack from what we call standard template library in C++. I will have to use this include statement #include stack. And now I have a stack class available to me. To create an object of this class, I need to write stack and within angular brackets data type for which we want a stack. Then after space, name or identifier. With this one statement here, I have created a stack of characters. Let's now write the core logic. This n in the signature of reverse function is number of characters in string. This array, as we know, array in C or C++ is always passed by reference through a pointer. This C followed by brackets is only an alternate syntax for asterisk C. It's interpreted like this by the compiler. Okay, so now what I'm going to do is I'm going to run a loop starting 0 till n minus 1. So I will traverse the string from left to right, and as I traverse the string, I will push the character onto stack by calling push function. I will use a statement like this. Once push is done, I'll do another loop for pop. I will run a loop with this variable I starting at 0 going till n minus 1, and I'll first set ci as top of stack, and then I will perform a pop operation. If you want to know more about functions available with stack in STL, like their signatures and how to use them, you can check the description of this video for some resources. This is all I need to do in my reverse function. Let's run this code and see what happens. I need to enter a string. Let's enter hello. This is what I get as output, which seems to be correct. Let's run this again, and this time I want to enter my code school. This looks alright too, so we seem to be good. So this function is solving my problem of reversal. Let's now see how efficient it is. Let's analyze its time complexity. We know that all operations on stack take constant time, so all these statements within loop, inside loop, will take constant time. The first loop is running n times, and then the second loop is also running n times. First loop will execute in big O of n, and the second loop will also execute in big O of n. The loops are not nested, they are one after other. So in such scenario, complexity of the whole function will also be big O of n. Time complexity is big O of n, but we are using some extra memory here for stack. We are pushing all the characters in the string onto a stack. The extra space taken in stack will be proportional to number of characters in the string, will be proportional to n. So we can say that space complexity of this function is also big O of n. In simple words, extra space taken is directly proportional to n. There are efficient ways to reverse a string without using extra space. The most efficient way probably would be to use just two variables to mark the start and end index in the string initially. Let's say I'm using variables I and j. Initially I for this example is 0 and j is 4. While I is less than j, we can swap the characters at these positions. And once we have swapped, we can increment I and decrement j. If I is less than j, we can swap again. And once again increment I and decrement j. Now I is not less than j, I is equal to j. At this stage we can stop swapping and we are done. This algorithm has space complexity big O of 1. We are using constant extra memory here. Time complexity of this approach once again is big O of n. We will do n by 2 swaps, so time taken will be proportional to n. Definitely because of space complexity, this approach is better than our stack approach. Sometimes when we know that our input will be very small and time and space is not much of concern, we use a particular algorithm for ease of implementation, for its being intuitive. It's clearly not the case when we are using stack to reverse a string.